So let's begin. The learning objective for today, we are all animals, and in human vision, there's a specific range of light and action spectrum that upon entering the eye functions to entrain our circadian rhythm. Beyond visual input, it's a biological response to light. We'll identify the action spectrum, learn about its role in human health, how it's quantified, measured, and calculated, or documented as equivalent melanopic lux, EML, which is used in one of the light concept sections in the Well Building Standard version 2. We live in a world full of beauty, contrasts, complexities, and dualities. We're all familiar with the lighting design process in that it is one traditionally that revolves around the visual process. But moving beyond visible light, where we talk about the qualities and functions of light, we can move beyond visible light with new scientific knowledge. You may have seen photos like this before. We all know that daylight affects people and animals differently, and we have new scientific knowledge. In the early 2000s, a photoreceptor was discovered in the human eye that collects information that's non-visual and sends signals to the brain for circadian stimulus. So as you can see here in these photos of the sun, from sun up to sunset, the sun goes through different color temperatures and intensities of lighting power. So with the new scientific knowledge, a new duality has emerged. Visual lighting design, which we know and are very familiar with, but also circadian lighting design, which is the new paradigm. It's not just a fad, but it's real science and actual knowledge that is meaningful for our biological system. There are direct and indirect effects of light. Direct effects control our mood, alertness, learning, and cognitive functions. Indirectly, light affects our metabolism, our wake-sleep cycle, and our cardiovascular system. All of the indirect effects are driven by melanopsin expressing receptors in the retina. So what should we do? First of all, don't panic. Personally, it's really good to get outside every day for at least 30 minutes in the morning. With rain or shine, getting a dose of healthy light, because the circadian spectrum exists in daylight, is important. Professionally, we want to evaluate what types of projects might be good candidates for circadian lighting design. Not all projects will be suitable. Offices, schools, hospitals may be more suitable than industrial or manufacturing facilities. Residential projects, depending on the scope and the scale. Restaurants and hospitality, maybe not so much. You don't need circadian stimulus lighting when you're going out to dinner. But let's learn more about what is involved. So in our eye, this is a little diagram that shows a cross-section through the retinal layer is composed of many layers. And in this diagram, the yellow arrow on the bottom is the light is entering the eye. And there are recently discovered intrinsically photosensitive retinal ganglion cells called iPRGCs that are contained in the retina, and they have within them a photopigment called melanopsin, which is sensitive to light. Melanopsin is sensitive to the circadian wavelength, which peaks in mammals at about 464 nanometers. This corresponds to sky blue color in terms of how we perceive light visually. So this is the action spectrum for circadian stimulus. It's a bell curve, as you can see, as in a lot of sensory perception, and it occurs within a range of about 450 to 500 nanometers. So here's another diagram. The wavelength entrains our circadian rhythm, and the diagram on the left shows diagram cross-section through the cones and rods, which we are familiar with. For visual perception, there are cones that are sensitive to green and red and blue light, medium, long, and short wavelengths. The rods are sensitive to lower light levels. But down here in the front of the eye are the ganglion cells. They are also perceiving light, but do not send signals about vision to the brain. They send stimulation signals about the 450 to 500 nanometers to the brain, and that entrains and triggers circadian cycles in our biology. The diagram on the right here shows different wavelengths of light and how they are actually all connected to the brain, and they all contribute in terms of circadian stimulus. So breaking down this diagram a little bit, right here where the cursor is, the rods have a certain sensitivity to light, as shown by this curve, and the medium wavelength cones that sense green light are responsive along this curve. The longer wavelength cones that are sensitive to red light have this curve. The short wavelength light of blue that is visible peaks at this curve, and then the melanopsin sensitivity is this other curve. So overlaid together, they all send signals to the brain that relate to circadian stimulus. Here's another diagram. It's basically our biosystem's response to light. This overlays those curves on the same diagram in this drawing. And you can see here, the cones are shown as blue, green, and red cones. And they have each of their peak sensitivity curves. And then the rods, which are shown here, has this sensitivity curve. And the IPRGCs that are melanopsin sensitivity occur here in this curve. This is along the shorter wavelength. This whole band here is the electromagnetic spectrum. Short wavelengths on the left are blue, longer wavelengths and red within the visible zone are to the right. So here's another curve here to the right that sort of separates it out a little bit more specifically. It shows us here between 480 and 490 nanometers is the peak sensitivity for melanopsin in the IPRGCs. Again, these are non-visual receptors that send signals to the brain to trigger our biological cycles. Peak sensitivity for visual light occurs at about 555 nanometers, which is in the bright yellow range. So it all works together. One name for this new type of light is called melanopic lux, named after the photopigment melanopsin. Melanopic lux is different and measured in the vertical plane at eye level to evaluate its effectiveness for circadian stimulus. So different light sources, as you can imagine, have different amounts of melanopic lux within them. So since we know that the 450 to 500 nanometer range is in the bluish color tint, a light source like blue sky is going to have more melanopic lux than the flames of a candle, as shown here in these photos. So within white LED lighting, the different spectral power distributions will tell the tale of how much melanopic lux is within that white light. So as it says in our headline here, SPD, the spectral power distribution, is more important than CCT, which is the correlated color temperature. Color temperature, as you may recall, is the apparent warmness or coolness of a light source. And then there's another thing called CRI, color rendering index, which we use to judge how well a light source visually renders colors, but CRI is not a relevant factor with circadian stimulus lighting. Spectral power distribution and color temperature are important factors. On the left here, you see a bunch of spectral power distribution diagrams of sources that have 5,000 Kelvin color temperature. On the right, a bunch that have 2,700 Kelvin color temperature. You can see that the curves on the right have a lot more red light in their energy bands. So that means that these will probably not have as much melanopic light. You can see here it talks about the CRI. Here's a light source that has a high CRI, but a warm color temperature, and it has not a very good melanopic to photopic ratio, that M over P. We're going to talk about that more in a minute, but that is an important ratio of melanopic lux to photopic lux. The circadian light relative to the white light that's in the rest of the spectrum. On the left here, we can see that here's another source that has a CRI of 100, but it has a very high melanopic ratio of 0.9. You can see there's much more blue light energy in this band of light. And that, judging from the look of that curve, is probably an overcast sky. So SPD and CCT are very important for melanopic lux. Color rendering doesn't matter. The key thing is for the SPD, the spectral power distribution energy, to be peaking in around the 460 to 490 nanometer range. So if it has a spike that looks similar to what's in the curve in the spectral power distribution, that's a good thing. Spectral power distribution is the wavelength from short blue light to warm light in the visible range, and then the relative power in spectral energy. So the interesting thing is the melanopic lux does occur within the visual range. So that's why the melanopic ratio is important. There's a lot of information on this slide. The way the melanopic ratio works is if you take the melanopic lux divided by the photopic lux, which is visible light, that becomes the M over P. That is the ratio of melanopic light to photopic light emitted by the luminaire. That you'll call the MP ratio, sometimes it's called the R ratio, or sometimes it's called the EML ratio, or equivalent melanopic lux ratio. The key thing is that the closer the MP ratio is to 1, the more effective it is for circadian stimulus. The MP ratio is a figure provided by the light fixture manufacturer, and that information is garnered from the SPD test data in photometry. You can see here a little table from a spec sheet of a lighting manufacturer. They are showing you that the color temperature of these 3 light sources of 3000 K has an MP ratio of 0.74. Here's a 3500 K source, has an MP ratio of 0.83, and a 40 K source has a 0.95 MP ratio. So the 4000 Kelvin source in this example has the highest MP ratio of 0.95. That's very good. That means that 4000 color temperature light source, because of its spectral power distribution, would be more effective at creating circadian stimulus lighting than a 3000 K source with a lower ratio. We'll get more into that, you'll understand. So equivalent melanopic lux, EML, is the MP ratio of a luminaire multiplied by the vertical photopic light, abbreviated EV for vertical at eye level, gives you the equivalent melanopic lux of circadian stimulus at eye level. The important thing is that when we measure circadian light, it's measured at eye level in a vertical plane. So this formula you'll see written a couple different ways. It's written with examples at the bottom here. Here's the vertical illumination in lux multiplied by the MP ratio gives you the equivalent melanopic lux. Here it is written another way. They're just calling it out as the lux multiplied by that ratio is the equivalent melanopic lux. This is a more explicative rather than the shorthand formula over here. So the way this formula works, I've got an example at the bottom of the page. If we had 200 lux vertical occurring at the eye level in a space from electric lights, and those lights had a melanopic ratio of 0.83, you would take that 200 lux happening at eye level, multiplied by the MP ratio of 0.83, and that equals 166 would be the equivalent melanopic lux value. In this example, it shows us how melanopic lux, measuring circadian light, should be measured vertically at the eye plane. But a lot of people do their calculations for horizontal planes because that's the way we've always done things for visual lighting design. And you'll find that there are ideally, we want to measure this in the vertical plane, but a lot of people are going to be doing their calculations for horizontal work plane. If that's the case, we can establish a ratio of the vertical light to the horizontal light. So for example, this ratio of vertical illumination to horizontal illumination, that ratio can then get applied to the formula. So for example, if we knew that we had, in one calculation, we calculated 400 horizontal lux at a workstation, which is approximately 43 foot candles, then that was measured as 190 lux, the relationship of the vertical divided by the horizontal, 190 divided by 430 is a 0.44. That ratio, which if you converted the lux to foot candles, would be 17.6 foot candles divided by about 39 foot candles. Again, that same ratio. So you would take the calculated value of 430 horizontal lux multiplied by that vertical to horizontal ratio, and then you would take these two numbers multiplied and then multiply that by the melanopic lux ratio, and that would give you equivalent melanopic lux. So there is a way to work with it from horizontal foot candles to vertical foot candles, then establishing the equivalent melanopic lux. But ideally, it's always best to measure light vertically. So you're probably wondering how much EML is needed and for how long. According to the Well Building Standard in their section 3 for lighting for circadian system, for regularly occupied spaces, to get one well point, there should be 150 EML, equivalent melanopic lux, between 9 a.m. and 1 p.m. daily. That's the important time to get melanopic lux. And that would get you 1 point, and it can be lowered or turned off after 8 p.m. You can gain 3 well points by having 240 EML between, again, 9 a.m. and 1 p.m. daily, and can be lowered or turned off after 8 p.m. I do not know exactly how they establish these EML levels, but it is related to circadian stimulus that is known to function to help keep people in sync with their biological rhythms. One thing that's good to know is there are worksheets and assistance available from manufacturers that have data. So there are companies that can provide worksheets and help you work through typical problems in a classroom or a work setting. The IALD, through their Lighting Industry Council, has endorsed the well rating systems guidelines and provided information earlier this year for designers relative to the well building standard. So it is an important factor that's getting traction in the industry. So now we have a couple of assessment questions, and I know this is happening quickly, but want to ask you a couple of quick quiz questions, of which there are 3. So in human vision, what's the peak wavelength of light for circadian stimulus sensitivity? Here's a blank curve. As we saw in the other diagrams, that peak is within the 450 to 500 nanometer range. And to our eyes, this looks like a sky blue light, which makes perfect sense since that is how human beings have evolved under daylight. Second question is, what metric name is used to quantify circadian light that's processed by melanopsin in the IPRGs, and where is it important to be measured? The clue is in melanopsin, right? So melanopsin senses the light, so we call it melanopic lux. And melanopic lux should be measured in the vertical plane at eye level. We want to see how much light of circadian stimulus nature is getting to the retina. Third question, one method used to quantify melanopic lux is to equate it to the vertical photopic lux, the physical visible light that occurs at eye level. What is the term that's used to express this ratio, right? It equates, melanopic lux equates to photopic lux. So the answer to that one is called equivalent melanopic lux. That's the equivalent circadian stimulus light level that has been established and upon in the design industry for providing a general equation factor for equivalent photopic lux to circadian stimulus. So the equivalent melanopic lux is a relationship to the visible light that occurs in a space. It has that relationship because not all of the light within the white light is going to be stimulating our circadian rhythms. Here are some really good links for more information. There's the WELL certified website. There's a link to the IALD document that is a 10-page document that talks about how they are endorsing the WELL building standards. The Lighting Research Center at Rensselaer Polytechnic Institute has done a tremendous amount of research on circadian stimulus and actually has slightly different methods, which would be very good to learn about. And we may cover that in another nano session. And of course, BIOS Lighting is another company that has done a lot of leading edge research on melanopic light and circadian biorhythms. So with that, we would like to say thank you and appreciate your paying attention during this brief program. I hope that it was useful, and there's a lot of information to cover, but we're trying to focus on this one bullet pointed topic for the action spectrum of circadian stimulus level.